Class example 3.2.1. For each relation in this example, we're going to first identify the range and the domain for each of the two relations. And then we're also going to determine whether this relation is a special type of relation called a function, and we'll talk about why. So for the first one, we have a relation that associates a number with a prime factor of that number. So for example, the number 4 has a prime factor of 2. The number 6 has a prime factor of 2. The number 6 also has a prime factor of 3. 8 has a prime factor of 2, and 9 has a prime factor of 3. So a couple of things that I just wanted to remind you of is that when we talk about the domain and the range, the domain is associated with the x values or the inputs. Okay. Our range is associated with the y values, or in other words, our output. Okay, so in this particular question, we see we've got a domain. I'm going to put a little d and a squiggly bracket here. And what we're going to do is we're going to look at all of the x values in these ordered pairs. So I can see I've got the number 4, 6, 6, 8, and 9. So I'm going to write 4, 6. I'm not going to write the second 6. It's not required. So I'm going to write 4, 6, 8, and 9. Okay. For our range, that's going to be our output values, or in other words, all of our values associated with the y's. I can see I've got a 2, a 2, a 3, a 2, and a 3. So I'm going to write 2 and 3, no repetition in there. And I can see I've got the domain and the range stated for our question. Okay. The next thing we're going to look at is to see whether this relation happens to be a function. So the relation happens to be an associated number with its prime factor or with a prime factor, but a number can have more than one prime factor. So if we look at this particular example, we could first, if we wanted to, put our domain of 4, 6, 8, and 9 in a bubble diagram, our range of 2 and 3 in the other one. 4 has got a prime that's associated with a 2, 6 has got a prime that's associated with a 2, but 6 has also got a prime that's associated with, which is 3, 8's got a 2, and 9 also has a 3. So there's a lot of arrows going on here, okay? But in order for this to be a function, we must have a single output for every input. So in other words, we could write this as only one y value for every x value. It's like that function machine. I'm not sure if you guys ever did those function machines when you were in different grades, but you'd have some sort of thing, and then you'd have a function, and then it would have like an output, and it was like almost like a conveyor belt. Like if I took 3 and I added 7 to it, then I would get 10, right? This would be my input, this would be what my relationship is, and this is going to be my output. But there's no way that you could ever take 3 and add 7 to it and it come out to a different number than 10, right? So I would call these guys function machines. So when I look up here, I can see I've got a problem with the number 6. The number 6 has 2 prime factors. It has a 2, but the number 6 is also associated with the prime factor of 3. So in this particular case, there is not a single output for every input. If my input is 6, I have 2 separate outputs here, and this is not okay. It's still a relation. It's still something that exists, but this is not going to be a function. It's still a relation, and it's because we have 2 outputs for the input of 6. Now you could also say because we have 2 y values for the x value of 6, and that would be similar. Okay, question B. What month has this number of days in it? So we've got January, February, March, and April. We've got either 28, 30, or 31 days. In this particular case, we are looking at our domain as either the x values or the inputs, which happen to be the first thing. So we've got January, February, March, and April for our domain. and our range is associated with the Y values, or in other words, the outputs. And these months are associated with either 28 days, 30 days, or 31 days in those months. Okay. And the next thing we need to do is determine if this relation between months and days in the month is a function or not. Okay. And so I can see that January is only going to have 31 days. I can see February is only going to have 28 days, not a leap year. Okay. March is only going to have 31 days, and April is only going to have 30 days. So what we're trying to say, for example, is April is an input. Okay, that's what our domain is going to be. We could pretend it's like an X value. It cannot have both 30 and 31 days in its month. That doesn't work. Okay, but that doesn't mean that both January and April could both be 31 days. So notice here when we had April and we said it was going to 2 separate outputs, that was not okay. Well, in this particular case, we have 2 separate outputs, but each of them only have a single, 2 separate inputs. Each of them only have a single output. It just happens to be the same output, but this is actually allowed. So the number of days in a month is actually a function. So we'll write yes is a function. Only one output for every